All right, so now we're on to depreciation diminishing value method. So what you need to know about the diminishing value method is, unlike straight line method, it doesn't go down each year by the same amount of money. What it does is it loses value at a percentage rate. Okay, so each time it'll be a percentage of the value of that year that it has fallen to. And because of this, you will probably recognize the formula is very similar to one that we have used before. Compound interest. 1 minus A over 100 I. Oh, sorry. N. Okay, and so basically what these all stand for, let's have a look. FV is just future value. Now really, it's kind of the same as the total amount when we look at compound interest. PV, present value. So what's it worth now? Kind of, you know, what'd you buy it for? What's it, you know, what's it worth right at this moment? Or the original kind of value there at present day. This, again, kind of like principal. You'll notice though that unlike compound interest, we're not adding. So because it's depreciating and it means that the amount is going down each time, we're going to be subtracting from one. Our A is our annual depreciation rate. Okay, and then over 100, obviously, because it's a percentage. N is our time in years. Okay, so here's what we're going to do. We're going to do this first example. So our first example, and we're going to use this formula. So we have a car that is at present worth $24,000. It depreciates at 15% per year. And so we're going to use the diminishing value method to find its book value in 5 years' time. So we're basically looking at what's it going to be worth in 5 years' time if we want to sell the car. Okay, so the first thing is to write our formula. So FV equals PV 1 minus A over 100 to the value of N. Then we're going to plug our values in. Actually, that is my bad. We should always make sure that we identify them. So future value is what we're finding. Present value, 24,000. A, our appreciation rate, 15%. I should have done this in the beginning. N, 5 years. Okay, so always identify the information that you need, write your formula, plug them in. So our present value, 24,000. 1 minus appreciation rate is 15 over 100 to the exponent 5. Okay, so from there, we can look at 24,000, and if I do my 15 over 100, 1 minus, you know, that amount, I end up with 0.85 to the power of 5. So I put that in my calculator, 0.85 to the power of 5 multiplied by 24,000, and I basically get, or I should actually approximately get, $10,648.93. Now I've rounded obviously to 2 decimal places because we're dealing with money. So the car will be worth about $10,650. Okay, so about, we can round that up. It's almost $649. We can round up. Okay, that one, not too bad. But example 2, a little bit different. So if we have a little read, Jules bought a fairy floss machine for a sideshow for $6,000. He estimates that in 6 years it will be worth only $1,500. What percentage depreciation should he use each year? So now we're looking at doing a little bit of manipulation of the formula, or basically plugging in things that we're not really used to not knowing. So first of all, let's identify what we know. So we've got our future value. So he estimates in 6 years it will be worth $1,500. Our present value, he bought it for $6,000. Appreciation rate, we don't know. That's what we need to find out. And our time is 6 years. Okay. Now, write our formula. So, future value, present value, 1 minus A over 100 to the n. And then we plug in what we know. So, I know future value, 1,500. I know present value, 6,000. I don't know my rate, but I do know that that's to the power of 6. Okay, so what I do then, I need to start getting rid of some stuff. The first thing to get rid of, if I went A, then I divide by 100, then I took away then 1, then it was taken away from 1 and put to the power of 6, then multiplied by 6,000. So I'm going to divide by 6,000. So that will get rid of this one for me and put 1,500 over 6,000, which gives me 0.25. So this bit still remains the same, but because I divided by 6,000 on both sides, this one's gone and I brought that one down. From there, what I need to do is get rid of this. Now, in order to find that, I need to take the 6th root of this number. So I'll actually write that one in for you. So I have to actually do the 6th root of 0.25. Okay, technically I'm putting this one too. So that will leave me with 1 minus A over 100. And the square root, 6th root of 0.25, which is 0.7937. It keeps going. I try and use exact value. I could use a fraction there, would be better. We don't want to round until the end where possible. So then basically if I've got this 1 minus this amount, what I want to do, I might just take this amount from this side, so I'm going to add it over here, 0.7937. I'm going to, sorry, I'm running out of room because of the side there. I'm going to add because that's the bit I'm taking away, okay? I'm not taking away 1, that's positive 1, that's negative A100. And that leaves me with 1 on this side. Then, because I don't want these on both sides, I'm going to go A over 100. And instead of adding this, I'm going to take. Now, what you could also understand, depending on how good your algebra is, because this is one take, okay, this is actually positive 1 and this is negative 1. So if I actually put this 1 on the other side with this one here, I'm actually going to have it as a subtraction because it's a positive. So you could also skip and do it that way. From there, I'm going to do that subtraction and I end up with 0.2062 and it continues. And therefore, now that I'm dividing by 100, sorry, that will be 100. If I then multiply by 100, bring that up to a fraction, bring that up to a percentage, that actually means I'm going to have 20.62 thereabouts. Actually, I think it rounds to 6.3. Let's make that 6.3. And I'm going to round 2 decimal places. So, therefore, you should use a depreciation rate of about, because of course we have to round, 20.63%. Okay, so hopefully you can see the links between the compound interest formula and the diminishing value method for depreciation. Really, that's the only thing that is different. Instead of adding, it's subtracting. And because depreciation is a loss in value, that should remind you. Make sure you've actually got the formula and what these all stand for. And again, as long as you identify your information, plug it into the formula and then follow those steps as you go, whether you're finding future value or whether you're finding present value or the appreciation rate. You can do either of those. Plug in what you know and step through one at a time, so that you can work all of those out.